Hey folks, join me for the build of this Black Walnut dining table. This was both one of my favorite tables to build, as well as a time when I made one of my biggest mistakes. This customer reached out and was looking for a new dining table for his house here in Washington. Together, we went through the process of selecting one of a number of slabs that was available here at my local wood dealer, Live Edge Hardwoods. We ended up selecting this beautiful black walnut slab. You can see how large this slab is, and this is definitely on the upper end of the size of pieces that I'm able to work by myself. These builds start out by removing all of the bark. Bark on a tree consists of two parts, outer bark and inner bark. Outer bark is what people typically think of when they think of bark, and that's that thick, rough outer portion of the tree. This is usually removed using a hammer, chisel, and a healthy portion of elbow grease. Inner bark is a much thinner layer and sits directly under the outer bark, between it and the sapwood. I usually remove this using some form of wire wheel. It's important to get all of the inner bark removed to allow the epoxy to strongly adhere to that inner sapwood. I began by using one of the nylon brushes, but you can see that that's doing almost nothing to the surface of this wood. I then switched to a steel brush, and that was significantly more effective. After tidying up the live edge, I'll then rough cut the slab to fit into the epoxy mold. Again, using here my favorite saw, Big Bertha. This slab ended up coming in pretty flat, and that is a testament to the effectiveness of both the drying process and the flattening process they have at my supplier. After rough cutting, it's time for the cut that'll decide the final aesthetic of this piece, and that's the long cut down the middle. As I was making this cut, I again had to use the trick of sticking a wedge into the kerf as the blade was progressing through the slab. Depending on the growth patterns of the tree, there can be a significant amount of residual stress in the wood. This can act to pinch the saw blade as you're making a cut. The worm drive on this saw doesn't typically have a problem, but I try to make it as easy as possible on the tools. Once all the rough cuts are made, I'll come back and clean up all of the crevices. These slabs need to be immaculate, and there cannot be even a hint of bark left on them. This application is where the nylon wheel shines. It is soft enough to not leave any harsh marks on the wood, but hard enough to get in and get any of that loose material out. The motto is, when in doubt, get it out. It's not only the bark that needs to be removed, there's often soft spots like this that need to be addressed. You don't want this type of soft wood to be present in the final piece. You can either entirely remove it like I'm doing here, or stabilize it with an epoxy or a CA glue. There are other products out there, but these are the simplest. Another handy trick is to come in with a torch and burn off any of those residual hairs that have been left behind. A final pass with 80 grit on the orbital sander will help to get a nice uniform, rough surface on that edge. After the wood has been final prepped, we prepare the layup table. This is a sheet of high-density polyethylene that epoxy won't stick to. The layout that you choose in this next step is what will determine the final look of your piece. I'll build these usually 1 to 2 inches larger than needed on each side, which allows me the freedom to cut the piece to its final exact dimension after it's built. This will produce a bit of wasted material, but allows you to get an exact dimension of the final delivered piece. There's a lot of different ways you can choose to make an epoxy mold. What I went with was building a 4-sided melamine frame. This starts by taking a large piece of melamine and cutting out strips that are about 1 inch taller than the height of your wood. You'll then want to figure out a way to make sure those corners don't leak. What I went with was brad nails and caulking from the hardware store. Nothing special about the materials used here. I simply use the cheapest caulking I can find because I go through so much of it. Part of my motivation for making these videos is to show others how simple it is to build these kind of tables once you get a little bit of experience. I learned an immense amount on how to do this type of work from YouTube videos, and I see this as my opportunity to pay back to the community. After getting the corners sealed, you'll want to seal the bottom faces. The more caulking you can get here, the better. You really want to make sure that this thing is as sealed as possible to try to prevent any of that epoxy from leaking out. As an additional measure to try to make sure that this mold wasn't going to leak, I mixed up some tabletop epoxy and used that on top of the already cured caulking. Caulking stays soft for about 24 hours, so you want to make sure that it has some time to set before you either pour your main epoxy pour or coat it with this epoxy top coat. After the mold was complete, it was time for some experiments to determine the final epoxy color. One thing I learned through this process was that epoxy dyes look very different when dissolved in water than they do when dissolved in epoxy. I ended up needing to use my deep pour epoxy to run the final tests so I could be very sure that before mixing all of the gallons for the final pour that I had the exact ratio of dye to epoxy. I ended up finding that 1 drop of dye per 400 milliliters of epoxy gave that perfect, smoky, transparent look, whereas 2 drops per 400 milliliters made the epoxy almost completely opaque. After establishing my mixture ratio, I was ready to put the seal coat onto the wood. Performing this step will help to seal in those edges and prevent any of the air that is trapped in the wood from coming out and producing bubbles when the main body of the epoxy is poured. It's also a bit satisfying. There's something nice about seeing that fresh layer of epoxy go down onto that wood surface. Performing the seal coat is not required. I do it because for me, it's absolutely critical that these edges are immaculate and that there are no bubbles that exist in the final piece. Coming in with a torch pops any of the bubbles that were produced from brushing. It also heats and thins the epoxy, allowing it to additionally penetrate into the wood. This helps to additionally increase the mechanical bond that'll eventually exist between the epoxy and the wood. For all my geometry heads out there, we now need to figure out how to determine the required volume of epoxy needed based on the irregular shape of this river. My approach is to simply calculate an average width across both the top and the bottom of the river, then use that value along with the length of the table and the thickness of the wood to determine a volume in cubic inches. That can then be converted directly to gallons. You'll typically want to warm up your epoxy before you start the mixing process. Epoxy can be reasonably viscous, especially at low temperatures. You can choose to put the epoxy in a warm water bath to help reduce its viscosity, which will aid in the mixing process. You only get one opportunity to make sure the hardener and the epoxy are fully mixed. I'd recommend performing mixing on clear epoxy so that you can see if any streaks are left behind, which indicate that the epoxy has not fully mixed. Once you are very sure that the mixture is homogeneous, you can then add your dye. You want to be somewhat careful when mixing your epoxy to not allow the mixing paddle to ingest air and inject it into the epoxy. Despite how careful you are, there always will be some air left in the mixed epoxy. If you have a vacuum chamber available, this will be the time to use it. The chamber will pull out any of those lingering bubbles and allow the final pour to be crystal clear. This pour ended up being 12 gallons, which I added in 3-gallon increments. And since I knew the mixture ratio to get the perfect color, I was able to get all the buckets to match exactly. After getting all the epoxy added, I get to do my favorite part, removing the bubbles with the blowtorch. At this point in the build, things were looking pretty good. All the epoxy had been poured, the mold wasn't leaking, and the layout was just the way I wanted it. However, little did I know, I was about to be in for a big surprise. The epoxy overheated and went into thermal runaway. What I hadn't realized was that the temperature in my shop had slowly crept up. This was one of the few warm days here in Washington, and the combination of the shop temperature and the heat generated from the epoxy curing caused this epoxy to flash cure. This means that instead of curing slowly and consistently across the course of 3 days, it cured in a matter of hours. This flash curing is so aggressive that it causes the epoxy to deform as it cures, which is what caused the distortion of the top of the epoxy. Luckily, this doesn't affect the wood in a significant way. Now it's a matter of me trying to figure out how I can remove this epoxy and redo this pour correctly. Removing epoxy like this was completely new to me. It took a bit of creative thinking to figure out how to separate this cured epoxy from the wood. I nearly used every tool I had. I tried grinding it out. I tried cutting it out. I tried chiseling it out. I tried sanding it out. And through a combination of all of those, I eventually removed it. Both pieces of this slab were returned to raw wood. And for those of you playing tool counter bingo, I ended up using 11 different tools to remove the epoxy. After the epoxy was removed, all previous steps regarding wood preparation, mold building, epoxy pouring, etc. were repeated. The result is what you see here, a perfectly poured epoxy table. Then begins the arduous task of flattening the slab. My wood supplier provides the service of flattening slabs that people bring to him. I could have done that. However, my preference is to do this myself. It allows me to maintain the control and the consistency of the final piece. The way I flatten is with this rig I built. This is constructed from a material called 80/20, which is an aluminum extrusion. It's straight, it's flat, it's cheap, and allows for a reasonably nice setup. I've built a few versions of these over the years, and this is by far the best. The tool used is simply a DeWalt router with a 2-inch wide flattening bit on it. This is a pretty manual process and takes a few days, but boy does it result in a perfectly flat surface. This is done on both the top and the bottom. When complete, you're simply left with a few tool marks that'll come out easily with the sander. After removing a few garbage bags worth of wood chips, the table is ready to cut to its final dimensions. This is where that extra inch on all sides will be removed. It's important to me that I deliver a piece with the exact dimensions that the customer specified and not plus or minus a quarter of an inch. This 16-inch saw is one of my favorite tools and gets a lot of action in my shop. When making these final cuts, I ended up discovering something that I didn't initially understand what I was looking at when I first saw it, but turned out to be one of the most unique features I've ever seen in a slab. At first I thought this tree might have grown through a fence, and that I might have damaged one of my saw blades by cutting through this piece which looked like metal. What I eventually realized was that at some point in this tree's history, someone used it for target practice. There ended up being 4 total bullets exposed in this piece, 3 on the top surface and 1 on the side. When showing these to the client, he was equally as excited as I was to see this unique feature. Now is when this piece really starts to take shape. I start the sanding process at a very coarse grit, usually 60 or 80, so that I can very quickly remove the tooling marks from the flattening passes. It's important to keep in mind that wood and epoxy respond very differently to sanding. Also, each will be sanded to a different final smoothness. The wood will be sanded up to 220, then back down to 180 before it receives its top coat, whereas the epoxy will be wet sanded up to 2000. As you progress through the sanding process, you'll need to address any of the inconsistencies in the wood. This can include soft spots, chips in the epoxy, holes in the wood, etc. This piece also happened to have a large void on the bottom side that epoxy couldn't reach during the initial pour. This is solved by simply adding some more deep pour epoxy. Other types of defects can be addressed with some tape and a syringe. Good lighting is critical during this step. You'd be surprised at how many times you have to go back and forth over your piece to make sure that every inconsistency is addressed. Ultra-thin clear CA glue is a good tool here. It'll penetrate deeply into any soft spots and blend almost perfectly with the shade of the wood. For some of the larger holes, I'll use a thick black CA glue. CA glue is an acronym for cyanoacrylate glue, which is really just a fancy word for superglue. An aerosolized accelerator is sprayed on it, causing the glue to cure in about 10 seconds. It can be sanded immediately after. This approach really helps to speed up this cleanup process. Given the size of this table, you can see that it really is a challenge trying to work a piece this size with one person. After all the inconsistencies have been addressed, it's now time to work through the final sanding steps. The most challenging part of this is by far sanding the epoxy. It's a bit of an art form learning how to sand epoxy correctly, because it responds so differently than wood does to sandpaper. What I found is that you need to sand epoxy very slowly, stepping through every grit. Between each step, you'll want to make sure that you clean off any of the residual sandpaper residue before progressing to the next grit. Otherwise, you can produce what's called a pigtail, which is a deep, swirly scratch which often isn't seen until you've moved on to higher grits. A general rule of thumb is to never increase by more than 50% of your current grit when moving to the next step. I'll also add a layer of blue tape to the edge of the wood adjacent to the epoxy to prevent the wood from getting overly smoothed while the epoxy is being sanded. After the epoxy has been wet sanded up to 2000, the buffing process will begin. Even after only one pass with the coarse wool wheel, you can see a significant difference in the sheen of the epoxy. After that first pass with the wool wheel, I'll then step through 2 additional polishing passes, each with a slightly finer polishing compound than the previous step. This process, if done correctly, will result in an epoxy surface with no marks from the previous sanding steps. Despite attempting to have the blue tape protect the edges of the wood inevitably gets some degree of polishing from the epoxy polishing steps. This will result in the wood adjacent to the epoxy looking smoother than the rest of the table. To return the uniformity of the wood, I'll come in and very carefully use my sander to return the correct roughness to the wood. This step has to be performed extremely carefully. If the sandpaper even touches the epoxy, it will show. After having most of the heavy lifting done on the tabletop, I decided to focus my attention on assembling the base. I purchased this base, and when going through the assembly process, I found that one of the fastener holes had no threads. This gave me the opportunity to break out my infrequently used tap and die set. This carbide tap made quick work of this hole and allowed me to continue with the assembly process. A touch of medium strength blue Loctite will help to make sure that these fasteners will never move after they're installed. It's important to make sure the base is exactly centered on the tabletop. An additional nice finishing touch is, instead of simply bolting this base on and having these flanges rest against the bottom face of the tabletop, is recessing these into the table. And although nobody may ever see this, it helps to bring a bit of elegance to the design. The process is rather simple. I'll measure the thickness of the flange with my micrometer, then set that depth in my router. Since I already had the fastener hole locations marked out, I went ahead and drilled those first. The router is used to rough cut and remove the majority of the material. I'll cut close to my line with the router, then come back with the chisel for the final lines. I think I can safely say that sharpening chisels is not one of my favorite activities. I've made this simple sharpening station to make my life a little bit easier. A few passes here will get the chisel to the level of sharpness that I usually need. I'll be using threaded inserts here to mount my base. These inserts have a coarse thread on the outside for interfacing with the wood and a fine thread on the inside for interfacing with the bolt. Although not necessarily needed, I'll usually install these with a touch of super glue on the outside threads. After the inserts were installed, I decided that I wanted the edges to be just a touch straighter, so I came back with a marking knife and another round of chiseling. While working on the bottom side, I decided to add an additional personal touch to this table. I went ahead and embedded a laser engraved plaque with the Emergent Woodworks name and logo. This was placed under a layer of tabletop epoxy, then polished using the same process as the top. Every time this table needed to be flipped, it was an absolute Herculean effort. I certainly need to figure out an easier way to do this in the future. The last steps before applying the finish is cleaning. I'll clean the wood with mineral spirits and the epoxy with isopropyl alcohol. In this step, you want to continue cleaning until your rag is completely clear. It's important that there's no loose material left behind before you start applying the finish. In this case, I'll be applying Rubio Monocoat, which is possibly my favorite finish at the moment. It's a wipe-on hard wax oil, which means it's a combination of wax, oil, and a solvent. The benefits of using a hard wax oil is that if this table ever gets scuffed, it can be very easily repaired. The downside is that it's not necessarily the most abrasion-resistant finish. Other common finishes like lacquers or varnishes are more resistant to abrasion, but if they need to be repaired, they have to be entirely removed, which means that the entire tabletop would need to be sanded down to raw wood. To my eye, Rubio Monocoat produces one of the most elegant wood looks of the finishes I've experimented with. After the finish has been applied and allowed time to cure, it's ready for the ceramic top coat. This is the final layer that this table will receive. A ceramic top coat is a protective layer applied to the top surface of the table. The material is a mixture of a hard ceramic like silicon dioxide held in suspension with a solvent. This is done so the material can be applied as a liquid and when dried, produces an extremely durable, highly abrasion-resistant surface. This table got 4 layers of a ceramic coating to help it stand up against the wear and tear of this table being used as this family's primary dining table. After the top coat is cured, this piece is ready for its glamour shots. I absolutely love the way that this piece turned out. The bullets on the surface are a unique feature that I may never have the opportunity to see again. The final step was delivery. This customer happened to live a few minutes down the road from my shop, so I packed this up and drove it over. One step which wasn't shown was the installation of the support braces on the bottom. These will ensure that this table stays flat so that this piece can get passed down to this client's children. The customer also chose a set of chairs that matched absolutely perfectly with this piece. I couldn't have been happier with the way that this table turned out, and I think the client agreed. Thanks all for watching, and looking forward to catching you in the next one.